All right, everyone. Welcome to the Velocity Room. We're excited that you're here. And just a little bit about the Velocity Room. My name is Brad Tompkins, and I work with the Velocity Room. And you might be thinking, what is the Velocity Room? Well, I'm here to tell you. So, our goal and our mission is to get people together to talk about the changing, fast changing landscape of AI. There is a lot going on. Lots of things come out very fast in this AI world that we're in. And the idea is, how can we get a community together to talk about this and take on those challenges head on? So it's about sharing ideas. It's about talking with your peers. AI is at a point now to where we're all kind of trying to figure this out as we go. Yes, we've got some good things that we've done in the past, but as new things come out, it's a little bit of a work in progress for us all. So that's what we're here for. We do this with resources for you. We've got virtual and in-person events. Obviously, you're on a virtual event today. Again, welcome. And it's about getting the community together. So that's what the Velocity Room is. Now, more about the Velocity Room. We are a nonprofit organization. So we're independent, we're nonprofit. To join these webinars are free. To become a member is free. And this is about helping you on your AI journey. So it doesn't matter if you were just like, hey, I just, am getting started with AI. Maybe your company isn't doing anything with AI, but you want to move them in that direction. That's okay. We want you part of the Velocity Room, all the way up to people that are running agents in production for their companies. So regardless of where you are, we want to bring topics to you that will help you as you roll out AI, or you make the AI that you have even better. So you can be in the discover, the implement, or the innovate stage. The Velocity Room is here for you. Now, the Velocity Room is for practitioners. This is not for C-level. This is not for, people that are just like, all right, let's go do, let's set the direction of AI. This is for the practitioners that are actually doing the work, that are actually racking and stacking, that are actually logging in and, have the programming up for the whatever AI that you're working on. So keep that in mind. And please share with your colleagues and your peers if this is something you think they'd be interested in. Please share that information. Again, Velocity Room is free, and we want everybody to join. We got some events coming up I want to share with you. We've got AI Engineering World's Fair that's going to be coming up next week. Hard to believe. So it'll be at Moscone. We will have a booth there. We also have a community lunch. If you go to our website, you can sign up for that. If you're attending the conference, or if you're in the area and you just want to attend our event, ours is a satellite event. It's going to be at Spin, which is right next to Moscone. So more than welcome to join that if you happen to be in the area, regardless of whether you're attending the event or not. But it's going to be a fun event. Same type format for AI4. We'll be back in Vegas in August. And we are working on Velocity Room events that are our own events. So these will be standalone Velocity Room events. They're going to be a one-day event. They'll be free to join, free to attend, and we'll get into the nitty-gritty of all things AI. All right, so now we got our topic at hand. Silicon silos are dead. The GPU, CPU co-design and the post-GPU inference playbook. So obviously, lots of things are going on, with this topic. But I think, if you're like me, it was like, gosh, got to get all the GPUs you can. And now, whoops, CPUs is coming back into the picture, and they have got a lot of importance. I read an article the other day that the GPU to CPU ratio could be as high as 4 CPUs to 1 GPU. So anyway, to bring on our two speakers here, first we have William Fowler. Fowler is an AI solutions architect at Intel. Of course, they're a major player in all things AI. And with him, we've got Velocity Room board member, Richard Piazentine. Now, Richard is also with Cisco, but he is on the Velocity Room board and helps us out with moderating content and helping us out with all things Velocity Room. So, gentlemen, please join me on stage here, and the room is open.
All right.
All
Good
right.
morning. Brad, can you see us?
Yes, gotcha. Loud and clear.
Excellent. Well, good morning, everybody. Genuine pleasure to be here. Mr. Fowler, thank you for joining us in your first of what will, I hope, be many appearances at the in the Velocity Room. Just for the other folks on the webinar today, I do work for Cisco, but my primary role here is a AI evangelist, and very explicitly AI evangelist as an engineer. So I've been following and thinking about the implications of widespread implementation of AI in enterprise for quite some time. I think it's vitally important to all of us, society, our children, etc., that we get this right and we optimize the power of these technologies for what they can do for all of us, while avoiding the inevitable potholes that will be out there. And so perhaps, that's a good way for me to introduce just the subject of the day, which is, slightly dramatically posed, perhaps, that silicon silos are dead. I'm sure if Jensen was on the call with us today, he'd disagree. He wants to stay in the silo, and, that's just the way it'll be. But the reality is, what we're talking about today is when you are deploying agentic AI, and I'm going to make a specific reference to that. When you're deploying agentic AI in an enterprise for the purpose of generating shareholder value, which, if we've got the practitioner targeting in the audience correct, you should all go, yeah, that's what I'm trying to do. That is a related but different technical challenge than the deployment of large scale training clusters. Now, they are related. The Venn diagram overlap is high, but it's not a one-to-one mapping between the two use cases. And so in today's opening webinar of this series, we wanted to start talking about some of the considerations when you're building infrastructure for actual agentic workloads in an enterprise. So, Mr. Fowler, again, now forever to be referred to as Fowler, and that is now finally stuck in my mind. Welcome again, and you want to give the group just a little bit of background, tell them a little bit about yourself.
Sure. So, um, I am an AI solutions architect with Intel. I've been with Intel now about 4.5 years. So it's been kind of an interesting journey over the last kind of the start of the AI, generative AI world and to where we're at now. Prior to Intel, I worked for American Airlines for 14.5 years, where I did a lot of infrastructure work, eventually infrastructure architecture, cloud architecture, that sort of stuff. So been exposed and been around pretty much all of the technology involved from an infrastructure standpoint in kind of running and building data centers nowadays and running enterprise applications.
Hmm. Excellent. Well, then you will have all of the required scars to help our community not make their own. At least that's the hope. Um, you know,
Yeah, I've got quite a few.
yeah, don't we all? I'm actually only 25 years old, but as a consequence of my experiences with AI, I look like this. Anyway, um, I guess just a framing for the rest of the conversation. Agentic AI workloads, as I said before, they're inference heavy, which looks a little bit more related to the training side of the equation. But it's not just inference. Rather there's a combination of multi-turn, or they are a combination of multi-turn, stateful, quite latency sensitive tool using systems. And they create significant compute demands, including but not limited to the weight calculations. They also massively impact existing infrastructure. So one of the things that is near and dear to my heart when we're talking about large scale agentic AI utilization. And in our last webinar, we talked about the security and control plane considerations around agentic, for lack of a better way of describing it, agentic employees. Um, Another dimension of having those agentic employees onboarded is that, you know, they spawn hundreds of other agents. They have significant demands on their own tool sets, skills, etc. But then, more importantly, if you're somebody that's responsible for all of the IT infrastructure for an enterprise, they are also, I think, potentially the worst case scenario of X being the number of agents that gets, and you know, it increases exponentially as a consequence of them spawning other agents, and then uh, you know, X to the power of N, where N in this instance is the fact that each one of those agents operates at 100 times to 1,000 times faster than humans. So when you start to think about enterprise ERP systems, you think about just your sheer networking infrastructure. These things look a lot like humans on crack, which is probably not appropriate for me to say, but I mean that's you know, when you looked at it from a flowlet perspective, it would kind of feel a little bit like that. Your entire organization's on methamphetamine, and they're moving way, 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 way too fast.
Well, and as you get those agents going, right? I, I do like the metaphor of agents on, users on crack, but probably not appropriate, of course. But um, yeah, the amount of load that those things can put on those enterprise systems, right? It's and it can come out of nowhere, right? As agents are starting to go through their kind of reasoning process, right? All of a sudden they decide that they need to hit a specific service, and that specific service can get an influx of additional what look like users, but are really just the AI agents kind of asking it for more information. And, you know, so yeah, it's a very bringing these things into enterprises safely is an interest, is a broad topic.
It is, and you know, we got to start somewhere. So you know, maybe a few things, just you know, that are hopefully in this, you know, predicated on our prior conversation, but some things that we will touch on: questions of economics in design. So I know that's something that's near and dear to your heart. Love to hear your opinions around the economics of um, tokens, token costs, but in the context of agentic workloads. Um, you know, what changes in the infrastructure as you make decisions around deploying new types of infrastructure for agentic workloads, which I'm sure is top of mind for the audience today. And then, as I was talking about before, you know, how do you think about guardrails or scaling capacity systems when you have agentic workloads that, you know, hit your legacy systems unexpectedly, right? The enterprise can't go down, so you're going to need a backup plan or a control plan associated with how you deal with that. So we'll start a little light. So I'm just going to throw a question at you. When you hear silicon without silos, you know, when you're talking to customers every day as the Intel AI architect, what siloed thinking do you think is most damaging that you hear?
So probably the most is that AI is equal to GPUs, right? Um, I think probably the better part of last year, that was kind of the common,
Mhm.
common thought. I think as we came into this year, it's been a little bit more. We've seen a lot more kind of acceptance of other kind of accelerators come into play, like TPUs and custom ASICs and things like that. So I think, and then of course, as you get into kind of the CPU side of the agentic piece, right, talking about the load that you're putting on the enterprise services, all the extra pieces that you have to kind of orchestrate around agentic, right? So The inferencing happens, it very likely still happens on a GPU or maybe like a TPU or something like that. But then a lot of the other work ends up getting pushed out to CPUs and things like that. So that would probably be one. The other one that I would probably say is and this would be this is an interesting one because we come from a world where it used to be you can measure things, measure system performance really well, get a benchmark and things like that. And you could kind of expect the same performance out of it when you put it into production. But I think as we get into some of this agentic um, stuff, the idea of I have a I've run a benchmark of like, here's how long it takes this model to generate this number of tokens, right? And then I go and put that into production and it's going to look radically different because, well, the agent's going to be asked different questions in production. It's going to be doing different tasks, using different tools. And so you can't just design around kind of the benchmark and performance of just the model anymore. You have to kind of look beyond that and look beyond. So it's looking beyond accelerators and like the typical GPUs and things like that, but it's also looking beyond kind of those kind of standard benchmarks around, hey, here's how many tokens per second I can generate.
Yeah, that's really interesting thought process, and I hadn't thought about this in our last conversation. You made me think about a bunch of things I hadn't thought about before as well. What's the SLA? So if you're the IT infrastructure lead, how do you define an SLA for your community of users for the infrastructure that you just built, given that the performance is it's recursive, really. It's like the snake eating its tail because the performance of that infrastructure you put in place is directly related to, in an unpredictable way, the questions and use cases that your wildly creative employee base is going to come up with. Right. So that's a really interesting. Like, how do you characterize? I mean, I think we need it. Brad's still on the line. Brad, take a note. We need to think about a topic set for the velocity room around characterization and SLAs in AI infrastructure. What's the new world order of how a AI architect, as an example, in an enterprise is measured on whether or not they've done their job correctly? It's a really interesting one.
Well, and
Go ahead.
because yeah, it's the typical benchmark around generative AI was at tokens per second. With agentic, right? Um, that's important from a cost perspective, but it's not the end goal. The end goal is a completed task, a successful task, right? And so you almost get into task per second or task completed successfully. So there's a lot of extra metrics that you potentially have to kind of bring to bear there.
Right, right. I mean, I can envision a world in when it's, literally the IT professional of tomorrow is measured by a would you recommend score from the user base because you can't characterize just about anything else, right? But let's hope we can do something a little more sophisticated.
Hey, I had a question I wanted to jump in here and ask, and maybe we can kind of go back and just kind of level set. So the question specifically was, why does AI equal GPUs? And I know we kind of touched on that earlier, but I think if we could just kind of go back a little bit and talk about, yes, in the beginning it was very GPU heavy. Why was that? Now, obviously, we've got, ASIC chips, we've got CPUs, we've got NPUs, we've got all these kind of things. So just, for the audience that might just be getting started on this, let's just level set on the different types of chips and their purposes. That would be great. I'll hand it to y'all to take it away.
Well,
Yeah, I
that better
can.
be color.
Yeah.
Yeah.
So we actually did a little bit of research and analysis on this earlier this year, and we got a white paper that we published around it. So in the very beginning of the generative AI process, or kind of uh, change, the the typical interaction was a user would submit a request to an LLM, right? A model of, and the model would run inference and produce produce an output, right? It would be, hey, write a poem, generate an image, or write this code for me, right? It was kind of a one shot in a sense where it would be like you ask the question, the LLM responds, and that's it, right? Eventually, we added stuff like context and memory and other things that kind of compounded over time to make it easier for you to have more of a conversation with that AI or with the LLM. And then um, as we added some of those capabilities, we kind of slowly progressed to the point where where we're at now, where we have this agentic capability. So now, when you ask a model something, you can now that model can think about it, reason through it, and then it can go and use tools, right? It can take the output from those tools, um, remember the output, right, that came back, remember the original request, and it can actually pull in kind of feedback from a number of different tools to formulate the response that it gets, the users asked for. And that could be code, it could be a whole number of different types of actions that are taken. And so when you look and when you break down that agentic work, yes, there's still inferencing that's happening, and the inferencing may happen on the GPU. And I'll talk about the other accelerator types in a second. But then a lot of the orchestration work, the calling of the tools, the actual work that the tools do themselves, right? So if you've asked your agent to go do a query to a SQL database, right? That SQL database is now going to have additional load put on it from this agentic use case. And the data has to come back to the agent somehow and get processed. Typically, there's a little bit of a processing before the data comes right back to the LLM. And so with the uh, number of tool calls increasing, the amount of non-inferencing work, I shall say, increases. And that non-inferencing work tends to happen on CPUs of some kind. And now, if you want to think about the kind of standard types of accelerators that are out there, you've got the GPU, which is really good at parallel processing, right? And this is what we've been doing for AI for a very long time, right? Even back to the classical AI world. CPUs are the general purpose compute platform. They run your laptop, your tablet, your phone. They all have a CPU and of some architecture or another built into them, and they are what we typically have run enterprise services on for the most part, right? And GPUs have been kind of an accelerator to, for those highly parallelizable visual tasks, things like that. And what we're starting to see is an emerging trend of kind of custom ASICs that target AI workloads in particular. So you have things like Amazon's Trainium, Google's TPU. You have, there's Samba Nova's specialized ASICs and things like that. Those are designed around, specifically to target AI as opposed to the GPU, which was targeted first at being kind of the graphical accelerator for computers. So, and one of the things that I think too, is we think about this kind of, if you look at like the history of accelerators and such too over time, is there's pros and cons to using those, and we can talk more about that if you want. But and there's cycles and things that they go through, but I'll kind of leave it at that and make sure I answered the original question.
Well, it's prompting one in mind, and this is a genuine one. I like, most of the time I like to ask questions that I know the answer to. I genuinely don't know the answer to this question. If I were to look at a TPU or the Amazon, what is it called?
Tranium.
Atanium?
Tranium.
Tranium, excuse me. chips, what do they most closely resemble? Are they CPU based with a highly specialized instruction set, or is it a completely different silicon architecture?
Uh, Generally speaking, they're going to look more like they're going to be closer in relation to a GPU in the sense that they'll still depend on a CPU of some kind in the system. And so you could have like multiple TPUs in a system or multiple trainiums in a system, and they would be leveraging a CPU as kind of to run the OS and things like that. So you would have kind of they, but from an architecture standpoint, and I'm not a expert on TPUs or trainiums in any way, shape, or form, but um, so they would be closest cousins to the GPUs since they're accelerators, and then but their architecture is then more focused on the particular math involved in AI, right? So GPUs are more programmable, very general purpose accelerators in that sense. And then as you get more specialized, you are actually designing more for the particular math that you're trying to run. So
Interestingly enough, when you look at the way tensor architectures were built, et cetera, they were actually built to capitalize on the visual processing capabilities of the GPUs that were available at the time. And if I understood your response correctly, you essentially have massively parallel GPU architecture, except its instruction set doesn't think about shaders and vectors and radians. It thinks about the whatever the symbolic language of inferences, right?
yeah, so like matrix math heavy, for
Right,
instance.
yeah,
Yeah.
okay, interesting. Well, and I mean, this is something that we have talked about in other TVR webinars. Um, there will be other architectures, and you're seeing that at a massive scale already. And so again, that creates great opportunity, especially for all the other companies in the industry. Far be it from me to say, but the people that invented the modern computing industry, aka your employer, the architectures are going to have to be multi-vendor by definition. And innovation isn't limited to pixel pushing. Innovation is, systems level design for optimized outcomes, which, I mean, I would argue that's the core DNA of Intel. But this isn't supposed to be an Intel spot, so I'll leave my fanboy elements on the backside there. Did you have another question, Brad, or I was going to switch into another one? Yep, Brad, you're on
We
mute.
did have a question come in, and I'm reading it live here. So this is, if TPUs is not critical, wouldn't that delay the task completion in an agentic workflow? Also, an agentic workflow interface is critical than other operations like tool calls.
Yeah, I'm not sure I'm following that question directly myself. I think,
All right, let me get clarification on that, and you can go ahead and continue on.
yeah. So some of the studies that we've done as well, Fowler, um, and again, just I happen to have a bit of a networking head. Um, One of the things that we've noticed, like, so the entire service provider the networking stack in data centers is all based on this idea of aggregation based on the asymmetry of traffic loads. Okay, right? I mean, like the
Yep.
entire architecture of with the exception of very specifically designed lossless networking architectures, intrinsic to them is this asymmetry concept. Some of the work or some of the studies we've done are showing that when you look at the workload between a user and an agent, it tends to be much more symmetric. And sometimes there is more from the user to that agent than the other way. Um, Interested in your perspective on that from a design, when you're advising customers on how they design their data center architectures.
It's, yeah, I mean, it's part of that is you have to remember that your end users are human, right? And the 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 number of so we always think about this in like input token, right? Input token sizing, because that's really what you're looking at is how many tokens is a user sending to the LLM, and you have to be prepared for situations where the user might say, "Here's a whole PDF, digest this for me,"
Right.
right? And so the and in those kinds of scenarios where the user sends a lot of data into the LLMs, into the agents, and then the agents are sending a small amount of response back because it's a summary or whatever, right?
Right.
You have, I mean, that is a little bit of a different design than we've typically used, where you typically, you know, the users would get back more than they sent in, right?
Yep.
So you're using a tool, you're using an application or something, and it's typically it could be streaming data to the user, it could be doing other things. So yeah, you have to allow for that, both from a compute, from a networking standpoint, because I mean you've got whole different designs to start to think about, where, if all of your users are uploading, 5 PDFs to the, per question, right? Or, lengthy PowerPoint presentations that are ridiculously large.
Yes.
And you can really end up in some interesting positions from an infrastructure standpoint if you haven't prepared for that.
Right.
So
Character,
100%. Yeah.
yeah, characterizing the accepted workloads is vitally important, and then planning for the unexpected workloads.
Well,
Uh,
so you can do some of that with guardrails, right? So you can limit the users, right, input tokens. You can say, okay, you can't just upload that 500 meg PowerPoint presentation because that's insane. Please don't do that, right? So you can put some guardrails in place like that, or you can prepare some compute, prepare by having enough compute on the back end to handle that. It's so it's a conversation around like you have to understand your business
mm,
and the process flow and kind of understand your users so that you're designing something that's going to actually work for them.
mm. So one of the spirits of the Velocity Room is the sharing of experiences. Now I know you work with customers every day. What's the most interesting agentic AI use case that you've advised customers from an architectural perspective on, and what made it interesting?
Oh, good question. So and this one wasn't necessarily, I guess, me directly, but a team member of mine. Um, so one of the, and I'm going to have to be very vague a little bit too.
Of course, protect the
So
innocent.
yeah, so one of I think the most interesting thing is taking like the typical kind of analysis work that humans would do,
Yeah.
where you have multiple data sources that humans would normally go to review. So, one of the things you can think of is like a financial sector, right? If someone is doing some analysis on a given company for investment purposes, you would look at multiple different sources. You'd look at like the SEC filings. You would look at, say, like past performance on the stock market. You would look at, recent public comments by the, executive members or C-suites, right? There's a lot of different research work that you may put into that. And the output of it would be the human giving some analysis to what to do in relation to this stock. Like, is this a good investment? Maybe hold, maybe wait. So the interesting thing is you start to look at like an agentic side of that is um, how do you get the same kind of result or similar kind of result with some amount of deterministic behavior, right? Without kind of so that was the main question on this particular use case was how do you get some more like a more deterministic kind of result without necessarily neutering the LLM, right? Because the LLM's that creativity, that kind of being able to look at that, do that human-like analysis of things. So, but they wanted it to be repeatable. They needed, there's audits and things like that. You have to be able to say, here's how we came to this result. And so there's that was an interesting kind of consultation there to kind of try to get a more deterministic result out of an AI type use case. And
Now, did that
that's probably the best one that I can share. There's others that I absolutely probably can't share that are probably cooler, but
Yes, but then some guys in black suits would show up at your house, so we're not going to go down that path.
yeah, I
Um,
like.
exactly. It's funny. So I'm going to switch gears now and go directly into infrastructure for a second. So one of the things that I know we have people working on is around infrastructure efficiency, utilization, and balancing if we just keep it super simple, balancing the amount of CPU compute, GPU compute, networking compute with NPUs, et cetera, and kind of balancing that against the workload demands, right? That's the problem set that everybody in the velocity room essentially has. In your experience, talking to your customers, working with their actual deployments, as they're racking and stacking Intel infrastructure, um, where are you seeing the most uh, I hate to use the word because nothing is really wasted, but where do you see the biggest issues in the infrastructure where customers are having an aha that they needed more here, less there? Just some examples, some experience on that. What's the most underfed part of the infrastructure?
So one of the right now, I would say the most underfed part of the infrastructure would be kind of the GPU accelerators,
Yeah.
where the inferencing is happening, because there's kind of we've been in the mode of deploy as many GPUs as we can,
Hmm.
as we can afford, as we can put power in, so we can get budget for whatever, right? And then partly because we didn't want to get left behind, partly because we knew we needed it. We knew we needed an amount of AI inferencing, so we bought the GPUs.
Right.
So now it's how do I keep these expensive GPUs busy? And as we get into kind of the agentic flow, um, what we've seen is that the GPUs tend to spend more time idle, I should say. It's not a guarantee. It just depends on the use case, but they tend to spend more time idle than people expected them to, right? Just because they're waiting on these task completions, they're waiting on these tool calls and other things. So that's where I would see some of that happening. And then the other side is I'm absolutely hearing from a lot of customers around how much they're spending on AI, and the number of tokens consumed to do kind of this agentic like these loops and things like that. It sounds contradictory a little bit because I just said that you're not feeding your GPUs enough, but then you're also generating a lot of tokens.
Yeah.
It's because more often than not, it's kind of like two models. If you're hosting your own AI, your GPUs probably aren't as busy as they should be. If you're
Right.
consuming an AI as a service like Anthropic or Claude or something like that, you're probably using way more tokens than you can afford.
Right. Yeah. You're damned if you do, you're damned if you don't.
Yeah.
Yeah.
So
Yeah.
it really is, and you mentioned this earlier, it really is becoming like a systems level problem, right?
Right.
It's not like we're shifting from that, hey, how many tokens per second can I generate to a how many how many useful tasks am I completing? You know, um, how many correctly completed tasks am I getting done per second, per minute, per whatever, right? And you're trying to optimize now that balance between all of your other compute resources and your inferencing capacity.
You and I talked about this a little bit the other day as well around, we talked earlier in this call about, the definition of the SLA for the IT professional that is deploying infrastructure. Um, it strikes me that uh, at this point in time, particularly for folks listening that are in the planning stages, plan for not just the definition of your personal success, right? So how's your board or your manager or whoever else going to measure your performance, but as a firm, you know, there has been a certain amount of hysteria around acquiring GPUs. Okay. We can have a philosophical debate as to why that has been. Doesn't really matter. It's happened. And I have heard from my own customers, yeah, we got a mandate down from, you know, the cloudy ether, uh, make AI work for shareholders. Okay. So the definition of a usable outcome strikes me as being very, very important. And define your objectives up front around what problems do we actually want to solve. Like try to bound them a little bit so that you can then assess what's the return on the investment, which is the generic bucket for what you're talking about. What is the return on investment for this AI infrastructure that we're building against the objectives of the firm, not the objectives of, and I put myself in this bucket, the starry eyed engineers that are just amazed at what can be done and think not about the total tokens, but rather the coolness and shininess of the thing they just did. So that discipline, and I'm old enough to remember the cloud and the onrush to the cloud, and my personal implementation of local LLMs looks a lot like my personal implementation of a hybrid cloud, so that I could try to move workloads between my VMware ESXi instance to Amazon. And then, when I did that with a training load that I was using, then I got my Amazon bill and I had a heart attack. It strikes me that we're kind of in that all over again, right? I mean, the repatriation of workloads. Have you seen customers have the token shock and then immediately go to, okay, I'm doing this locally because my GPUs that I went and bought aren't doing anything. I just paid Anthropic X millions of dollars. Now I'm bringing it back local.
Yeah, I mean, very early on in the generative AI world, I mean, we worked with a customer who they were they're an education customer, and they were working on a um, very simple chatbot that leveraged RAG, and it used OpenAI, and they started doing the math on how much it would cost for them to scale it out to kind of the expected user base.
Yeah.
and it they couldn't do it. They couldn't afford it. And
Yeah.
so we helped them shift that over to, we actually ended up shifting it over first to a AWS instance just running using CPU. And then we shifted it to run locally on a laptop because at that point it was then on the end user to have a more, have a laptop that was powerful enough to run it.
Right.
And it wasn't their cost to kind of provide the chatbot was really down to any kind of fine tuning or kind of updates that they would have to push out for the application over time. And so I think that gets back to the kind of the comment you made earlier is like, are we are we doing what we need to do to make sure that the AI is in service of the business goals, right?
Yeah.
And not the other way around, not just
Yeah.
the shiny toy in the room. Um, and it takes understanding um, I go back to kind of the cloud analogy is great because if you think about the early days of the public cloud, people just lifted and shifted VMs from the data center into the cloud, and then they realized that that was a horribly bad idea, right? The bill was outrageous, and then it was eventually okay. We're going to design these things to be kind of cloud native, and then they realized that that was expensive to rewrite all the applications, and then it was okay, which applications would benefit from this the most? And so then you had more practical approaches to it. And then you had, here's the business value. Here's my application that needs to be, that's changing frequently enough to warrant putting it out into the public cloud where we would have kind of the requirement to push frequently, or it's the load is more dynamic, right? We're going to
Yeah.
run a sale this week and not next week, and so we need more capacity this week versus last week. So we have to get to the same kind of understanding with AI and the same kind of practice, and that's where you start to really you really start to apply some of the same methodologies, right? What's the business value of this given workflow, right?
Yep.
And what's it cost for me to use AI instead of using the previous flow? And so if you don't, and part of the problem there is you're going to have to understand how much that your previous uh, method of execution cost, right? So that when you go and look at the AI version, you can now, okay, here's how much the AI version cost. Let me do that comparison. Um,
Yeah, yeah, you're 100% right. I mean, and I can only speak from my own experiences, etc. You start to do wildly interesting things because you were never able to do them before, but that doesn't necessarily mean that they're driving economic value. Okay, so if
correct.
we just arc that side of it, a well-characterized problem that you can understand the before and then hopefully the after cost model, vitally important. So that's actually something, there's no right wrong pattern to that, but that's like a check mark, I think, for the practitioners on this call is, can I measure the before and then measure the after appropriately, which is exactly the problem set that we eventually got to in cloud, which is before I shift it, I need to be able to do the characterization ahead of time. And if we don't need infinite scalability because of the variability of what we're trying to do, don't use it.
Right.
So I'm gonna make a prediction. The next billion-dollar software company is going to be the company that figures out for enterprises the best way. And the frontier labs aren't going to be the ones that do this because they want you to always come back to their own brains. Always, always, always. And that makes total sense. Totally get it. But the next billion-dollar software company, in my opinion, is the company that nails effectively the hierarchical orchestration of what brain to use. What do I mean? You were just talking about the use of, you're damned if you do, damned if you don't. You have GPU sitting idle, or you have token costs that are stratospheric. And I'm old enough to be like a old school traffic engineer where Erlangs mattered. So anybody on the call that knows what an Erlang is will immediately understand why I'm using that analogy. But Um, that $1 billion company would be the one that figures out how you use your local Gemma 4 model that's occupying your GPUs at a good occupancy rate, at a good power to usable outcome level. And then you handle variability, the same variability that we used in the cloud model related to a compute requirement. The variability in this instance is the complexity of a unexpected question or task. And then effectively and transparently to the user base, move the processing of that request to the now AI equivalent of the scalable cloud. So that I personally, in my experience, and I'd be interested, anyone on the bridge that has an opinion about this, I do not think that problem has been effectively solved. Agentic harnesses are still too new, and the really capable ones are owned by people that don't want you to do anything other than come back to the cloud. So it's not like it's rich with innovation. OpenClaw and Hermes are the best examples. You know, their memory and LLM model utilization is, I mean, best in class, but I mean, the class is pretty narrow. I've just opened up to thoughts, and I'll just plant something else in your head. One of the things about Intel is that you provide now AI specialized processing at every level in IT infrastructure. And so these two things are very related. Your example that you just made about that customer who, you know, couldn't afford it until they had laptops that were capable of running part of the model. So comment, please.
I think your cloud analogy is really spot on, because if you think about it early on, and like we were managing public clouds separate from kind of the private clouds that we had, and then the companies that came out with the tools that could help us look across the public clouds and look across our private clouds at the same time and orchestrate across them and manage cost across them. Those companies did very well for themselves. And the public clouds were kind of late to that game because they didn't care. It
Yeah.
was like, why bother? I just want you to use more of my own instances. I don't want you to optimize your system. And so I think, and you're right. At Intel, we do have kind of across the board, and we have that's a lot of the discussion that we have with customers is, where does it make sense to run the model, right? Is it, and where do you run the inferencing? Where do you do some of the compute that you're looking to do with your AI solution? And um, we are absolutely going to have things like model routers and stuff that can intelligently send, like, look at the request and say, and we've got kind of examples of this. I wouldn't say we have, like, say, production level solutions quite yet, but I think it's just a matter of time before they're there. But um, that's where model routing falls in, because you have basically a small LLM that sits maybe locally on the laptop, and it's parsing the request and saying, this makes sense for me to run locally.
Mhm.
Or this is a bigger request, I have to shunt it to the data center, or I have to shunt it um, to uh, like a OpenAI or Claude or something, right? And so we're going to have solutions like that that intelligently route things around. And it may not even be based on complexity. It may be based off of cost, right?
Mhm.
Hey, this user's used up their budget for kind of the clouds, the Anthropics and OpenAIs of the world. So it's going to have to route locally, right?
Mhm.
And it's going to go slower, but they've used up their tokens for the month or whatever, right? So it's going to have to be aware of um, it's going to have to be aware of cost, complexity, but also, when you start to think about business critical problems, then that adds a whole nother layer in there. Because, okay, if this is a business critical problem, what's the SLA on the request? Is
Right.
it something that we can run locally on the laptop? Because if it takes an extra 5 minutes to process, who cares, right? Or we can shunt it to the data center because we've got a model, it's going to run effectively there, and we think we'll still meet the SLA by going to the data center. And because you don't want to get in a situation where your model router decides, oh, well, this is going to cost too much to send it someplace where it'll get done faster, but it's a business critical process.
Right.
So you're going
It
to have
begs
to
the
have,
question. Begs
yeah,
the question: can your model router say no? Do you allow it to say no in that instance? Right.
yeah. So it should be able to say no in certain instances, but in other instances, it's, hey, the SLA is what it is. And
Yeah. Yeah.
yeah.
You can almost imagine that the budget for tokens will be hierarchical in nature, but let's hope we don't get there. And engineers should just have infinite buckets, as far as I'm concerned. So I want to talk about
I
Intel.
wish. I mean, when did you ever have infinite buckets of cloud compute?
No, never, not once, not once. Unless I built it myself, and then I really didn't have infinite limits. Um, so I want to talk about Intel specifically for just a second, okay?
Sure.
Because um, one of the things that we could do a basic primer on a CPU instruction set versus a GPU instruction set. But more important, I think, is the thinking that's coming from Intel around okay, what are we going to do from an instruction set perspective that permeates, and this is, you're doing this on behalf of the x86 consortium, so it's not specific to Intel in the sense that you are contributing it to the larger community. But can you talk a little bit about optimizations that the entire x86 industry needs to adopt or is adopting, and that the architects of today need to be aware of when they're thinking about how they design out their AI infrastructure?
Yeah. So some of you may be aware of that Intel and AMD have started what we call the x86 consortium.
Mm.
And as part of that, we're working to kind of create standard instruction set extensions so that, because in the past, if, say, for example, when Intel announced we had AMX capability, the AMX capability on our fourth gen and newer Xeons, that wasn't present on AMD. And so if you optimized your AI workload to take advantage of AMX, you had to run on Intel. One of the things that we're trying to do as part of the x86 consortium is create at least a standard um, standard framework, right? The implementation on silicon will be different, but the framework of the instruction set will be portable. And so that's one of the things that we're working on to get to the point where um, we're going to be able to offload even more AI work onto the CPU, or more, and in particular, more AI inferencing onto the CPU. And it's going to be something that is going to be kind of universal across the x86 architectures that are out there.
Mm.
The and this is that's kind of the official spiel of it. And then the the Fowler take on things is, and I mentioned earlier about the cyclical nature of IT and of technology. And um, if you look at and trace kind of the nature of technology, you have kind of this race to commoditization. And so
Mhm.
when a new technology comes out, you'll often see these specialized accelerators pop up for it that will do it better and faster and cheaper than a CPU, because the CPU is designed for general purpose. And then over time, the CPUs become more powerful in a number of ways. One is you get kind of a better performance from a just the planes, say, like single instruction thread through the, single threaded performance through the CPU becomes better. But then you also get these instruction set enhancements over time that improve specific workloads. So over time, you'll see, I think, more of and the interesting thing too is that the software side normally catches up eventually too. And there's normally
Yeah.
kind of a convergence that happens. And I think we'll see that in AI, where you'll see you've got smaller models becoming better and better and better. And then you'll see the CPUs becoming better and better and better. And you'll see that kind of alignment there. And so over time, I think you'll see more and more of the actual inferencing work happening on CPUs just because it's not as complex to deploy and it's not as expensive to deploy and doesn't need as much power and so on and so forth, right? So it's that kind of commoditization cycle that we've seen in the past, and it's going to happen again. I think the interesting thing this go around is we've got a lot more architectures on the CPU side of things in play, right? So we've got x86, we've got ARM. It's going to be interesting to see how that dynamic plays out.
Yeah.
Just from a pure nerd standpoint, it's gonna be really interesting to watch that. But
Well, yeah, and the dominance of mobile and mobile applications that are doing local processing will also probably influence that sort of
oh,
battle
definitely.
back and forth, right? Just as an old school runner and gunner, I'm pretty sure if I go down into my basement right now and I dig deep, I will find a Turtle Beach sound card from my gaming rig from 2003. And so, to your point, convergence or commoditization of functions that are high reuse, right? Like, why do you have an FPGA? Well, because you're not 100% sure exactly how you're going to do something. So you do things in an FPGA. As soon as you lock and load it, you slam it into an ASIC. That we are in the FPGA side of the GPU compute world. And it's not that they're going to go away, right? But functions will be disaggregated to drive cost out of the system, right? And I know Brad's coming on because we're approaching time, but in the effort to educate our community, is there a place that you would suggest people go and do some reading around this consortium? Because I think that roadmap that you and AMD have agreed on or are agreeing in the process of agreeing, I know it's a work in progress. It strikes me that is a vital piece of information for somebody that's thinking about deploying infrastructure over the long haul.
Yeah, and I can share a link, and I'll look up a link and share that for additional reading, because the consortium publishes that sort of information.
Okay.
And then to see the actual implementation and timing, you'd have to talk to your individual AMD or Intel rep to kind of see where that lands on roadmaps and stuff like that. So,
You're not going to spill the beans for everybody
nope,
right now? No,
said
no.
I like my
Okay.
job.
Yeah, your corporate overlords are above you right now. I hear it. That'd be
But the
great.
other I think the
But
other aspect to it too, besides like that consolidation side of it and the driving costs out of it, is also going to be to drive the power requirements for it down lower and lower, right? Because power is such a huge part of that cost equation. You're
yeah,
going to see more and more work done to drive the power requirements down so that it's easier to do it on the mobile devices or on the laptops. And it's easier to do it in enterprise data centers where you don't have 120 kilowatts per rack from a power standpoint.
yeah, no, 100%. Brad,
So yeah, a lot of activity going on in the question, and some of these y'all touched on, but it was interesting, the conversation about how CPU is bringing an advantage to AI, and we talked about how GPUs are expensive. Fowler, you touched on this, and idle GPUs is a bad thing. So you've got to figure out how to feed those GPUs as much as you can. Then we were having conversations around SLMs and how the SLM is a better fit for CPU consumption. And really, instead of throwing a large LLM and everything in the kitchen sink at a particular problem, if you can reduce it down to a SLM that then could be done on CPU, that's going to be, first of all, available, second, less on power, and those kind of things. So that was interesting. Now, if I could go a little bit deeper on the SLM piece of it and how people are realizing, okay, we want this to run on a CPU. We want the inference to happen at CPU level. So therefore, the framework up above needs to be designed differently. Use different tools to make sure that that can run on a CPU because of the savings and the power and the benefit to having that run on a CPU.
Yeah, I mean, I would say that the idea of the model router, basically runs directly into this concept. All right. And so, just to use a Cisco example just for a second to talk about SLMs and the utilization of SLMs, Cisco went and built for our customer base an SLM that was trained on the entirety of Cisco's infrastructure management, security, management, and network operations, technical support, et cetera. It's not a multi-trillion parameter model, but by the same token, it doesn't need to worry about cat videos. All it does is advise customers on infrastructure problems. And that's a classic. Now, it's still running in GPU compute, so it doesn't go directly to this idea of being able to run locally on a CPU. But the point is, it is a use case specific SLM. And I personally think we're going to see a mass proliferation of the use of, maybe RAG optimized in some way SLM models that are much smaller and know how to say, I can't handle this, which is the purpose of the model router. I can't handle this. I need to bump it up to the next level. Fowler, you got a comment you want to make?
Oh, I absolutely think as we go down the line, using small language models that are either kind of fine-tuned or specifically trained for given use cases,
Mhm.
like you're already seeing some models published that are highly focused on coding, for example.
Mhm.
Um, they don't need to generate a cat video or something like that. So the more focused those get, the smaller they'll be, and the more capable they'll be on smaller hardware.
I mean, again, when I don't know the answer to the question, it's always dangerous to ask them. But are there examples of SLMs that can run on generic CPUs today?
Absolutely. Yeah. So there are a lot of llama models, for example, like 8 billion parameter models that we use all the time. And I use those in my agentic workflows and demos that absolutely run very well on CPU today. You've got models that are we the number that we always say or that was always published was around 20 billion parameters, but
Yeah,
it's as an architect, there's always it depends in there
yeah,
because it depends on what is the model quantized down to. What are you asking the model to do as from a concurrency standpoint, like how many users and things like that. Um, but yeah, we have plenty of model examples today that are small enough that they will run very, very well on CPU. And um, the Llama family is one, the Microsoft's, I think it's Chi family, I forget how you pronounce it, Phi.
mhm,
Their family has some small examples as well. Quinn has some small example models as well. And these are perfectly functional models that you couldn't tell the difference between them and maybe like a large Anthropic unless you were throwing really complex questions at it.
right. Yeah, I mean, even just instead of throwing a voice clip up to Anthropic and the associated costs associated with that, just having a local SLM do the model interpretation, right? Like
You- Google's
pre-filter.
got Google's got Gemini models that run on phones. So yeah,
Yeah, I'm running a Gamma 4 on mine, but I need to crank my quantization because my tokens per second is down at like 6. Right? It's either that or if there's anybody from NVIDIA out there, just ship me a 5090, will you? Because my 4090 is crying. Anyway.
All right, so we had some members sharing some information. Somebody mentioned about light LLM that will pick what LLM to use based off complexity. So I thought that was interesting, sharing out to everyone.
What?
yeah,
Sorry, what was the name of that?
it light
Light LLM,
Light.
LITE.
So we actually, Intel actually has a solution stack we call the Enterprise Inference stack. It's an open source stack built from open source tools, and we use Light LLM inside of that as to help with routing as well. So it's a very useful tool.
Okay, well, thank you. My job is to help the community learn, but the community just helped me learn something. That was
That's
good.
what it's all about.
Yeah.
So, Richard, I'll ask you this. I don't know if you'll be able to answer, but we had a specific question on what was the cost of that Cisco SLM that you mentioned earlier.
Well, it would depend on the framework of cost, and the short answer is I'm not going to be able to answer the question directly. I honestly don't know what it cost us to train that model. Obviously, our costs are, I mean, for us, it's given our entire service organization, it has just exploded their productivity. I mean, literally. And productivity for our services and TAC organizations is, solving real world problems in critical infrastructure. So the training cost for the problem that SLM, this is kind of goes back to the outcomes based assessment of costs actually that you were talking about earlier, Fowler. Um, it almost doesn't matter what it costs us because it's letting us solve problems at scale for our customers in infrastructure that cannot fail. And so, I mean, I can go and find out and see if that's something that we would provide out to the community. Just a rough idea of what did it take for us to do that. I'd be happy to do that. The other thing I would say is a lot of the work that we did in this area has been open sourced. So for the community, go out and look at Foundation AI and some of the work that's been done there. We did release these capabilities out to the community because it's a force for good.
Great.
Yeah.
Yeah, a lot of interest in that Cisco SLM. But I think you touched on it. I mean, these are things that, you or Cisco or whomever, they can take the open source models and then customize that, for whatever task is at hand. And this is kind of what the conversation's been about. It might be an SLM that's just focused on, Cisco white papers and Cisco best practices. And then that way you can pull that down and bring it in a more of a CPU heavy environment. I understand in your environment, you've got some GPUs. Obviously, Cisco's got a ton of data, so that makes sense. But as that balance shift, I mean, you can save a lot of money if you can be 50-50 CPU, GPU versus, 75-25. And lands, nobody wants to have GPUs just sitting idle.
Yeah. Amen.
Yeah.
And you could also, again, if we want to veer into what'll happen over the next 10 years for just a second, sand for all intents and purposes is free. Power is not.
Yeah.
Right. And you could easily envision a world where the cost of all of this is predicated on simply what your gigawatt production rate is going to be. Now, are we there yet? No, not even close. But that, and we didn't really talk about it too much, and maybe Fowler, because I know that Intel really leads in this area. But the power efficiency of token generation for an equivalent token task, not all architectures are created equal. Do you want to comment on power efficiency and some of the innovation that you guys are thinking about?
Yeah. So I mean, you could start by just looking at kind of the latest generation of our consumer laptop CPUs, right? The the Core Ultra 300 or whatever, Panther Lake, those are getting, days long battery life now, but yet they have the ability to generate a fair amount of tokens because of the capabilities of the GPU that's on board and the MPU that's on board. I was actually just reminded, so but as we are actually doing a lot of work to try to get the power per token down even further. We're doing research around and have working chips around things like neuromorphic, where you're now in the watts level for a chip. Um, and so that's going to be a little bit longer term before it runs general purpose. And um, you may see that kind of integrated into other solutions down the line potentially, or just standalone. Don't know yet because it's still kind of early, but that's the sort of stuff along with like the NPU. Like the NPU is such an interesting device too, because a lot of the video effects for Zoom and like the blurring of the background and stuff like that, that's happening using AI on the NPU if you've got kind of the NPU present on your laptop. And the NPU draws a small amount of power compared to like a GPU.
Right.
Um, and then as we get into kind of the data center and you look at like the GPU side of things, yes, we've got a GPU coming later this year that's going to be a very low powered, comparatively speaking. It's like 350 watts, targeted at inferencing. And you look at the CPUs as well, and the capabilities, like I said, that I mentioned earlier about over time, the CPU is becoming more capable. You're going to be able to do more with a lot less power there too. So it a big part of AI and AI at Intel too is we have to do this in a very responsible fashion, right? Because I mean, we see kind of the concern around data centers. We see the backlog in power, right? We just don't have the power to bring into some of these data centers to build them. We can't build turbines fast enough. So we have to use the power that we've got as wisely as possible and as efficiently as possible. And so that's where um, that's where it really gets back to that system level problem. In addition to you're optimizing your cost and your token generation now, think of it from a system level problem and say, okay, this problem's hard enough. This model has to run on a GPU. This actually works better on a CPU. How do we build a heterogeneous kind of orchestrator that can look at the entire system and start to optimize at that system level capability for power?
I
And
can't help but take this back to what you were talking about in terms of the consortium that you and AMD are working on. Because in the end, a single CPU clock tick through a instruction that is optimized for an outcome is always going to be power cheaper than the 50 or 60 or 100 ticks required in a more general purpose GPU model, right? And so that commoditization you were talking about earlier of function, in my opinion, also relates to power, right?
absolutely.
And so we're going to see that. I mean, the problem is it's a problem where it's the beauty of what we do. We're in the wild, wild west right now. There are no right answers. We're not even 100% sure that the current architecture of an LLM is the ultimate end game. All right. Which means, boy, it's highly probable at this point. Okay. And if it achieves AGI, it's not going to let us do anything else anyway. But we are in the middle of the singularity, everybody. And if you don't think we are, go and watch Moonshots. I can highly, highly recommend it. If you're on this call and you don't watch Moonshots, you're missing out big time. Anyway,
Well, so I want to touch on the AGI one because I've got an opinion on the AGI and whether or not the LLM architecture we've got is going to get us to AGI.
yeah, yeah.
And I don't think we're quite there yet. I
Mm,
think when you and the reason I think like that is if you look at the brain, right? Your brain has a number of different areas and they all kind of behave differently and they all have different functions, right?
yes.
So I think if you look towards the future, towards AGI, one, it's going to be some model that works in a heterogeneous fashion across a couple different architectures, both from
Mhm.
a hardware standpoint and a software standpoint. Because if you're going to model and behave kind of like a brain does, you have to be able to process, say, like images efficiently. You have to process text and speech efficiently. And today, shoving all that into one big model, that's not the
Yeah.
way that's not the way our brains work, right? Our
Correct.
brains don't work that way. Yes, it's a single organ, but it's broken up into sections where each section
Yeah.
is optimized for that particular type of processing. So I think it could easily look like something where we take these small language models that are very focused and very efficient in one area and
Yep.
combine those together to get to something that functions like AGI.
Yeah.
So yeah, it's going to be interesting to see the next couple of years and how that goes.
I tell all of my friends and family, I am the absolute biggest fanboy and optimist around AI, but at the same time, I got a big red button on the side of my telco rack and 1,000 gallons of propane for my generator outside. So, everybody, make sure you got your Boy Scout training on there and stay optimistic. Anyway,
Yeah, I keep a Boy Scout handbook around just
just in case, just in case. Good deal, Brad. Take us away.
All right, sounds good. So we did put the moonshots link in the chat. Richard told me about moonshots and now I'm addicted to it. It is fantastic content there and I love that style. But thank you very much for participating, everyone, today on this. I want a big thanks to Fowler and Richard for having this conversation. This is the type of conversation that we have. It's not necessarily PowerPoint, so that might squeeze in there sometimes, but like today, we didn't have that. It's not necessarily about, go buy this product or that product. It is about having conversations about where this is going. And we talked about how we are developing this as we go. We're all learning AI as we go. So that's the purpose of the Velocity Room. So tell your friends, make sure they become a member. Again, membership is free. This is for the practitioner. I appreciate the questions that we had a lot of good questions and good chat going on while these gentlemen were talking. And I hope to see you at AI World's Fair next week. Hard to believe it's almost here. And we will be at AI4 as well. So make sure you sign up for the emails that we'll be sending out to you. And that way you know all the things that are going on in the Velocity Room. If you have content you would like us to cover, send it our way. We will get it on the agenda and make sure we have conversations about things that are important to you, the Velocity Room member. With that, we will wrap it up. Any final comments, gentlemen?
I just want to say a personal thank you to Fowler for joining us today. I appreciate your insights, and it was great meeting you.
Absolutely, and thank you for having me.
Mm-hmm. Good deal.
Sounds good. Well, we will close it out. Thanks, everyone, and we'll see you at the next Velocity Room event.